Hi and welcome back. Tonight's notes are going to be on area ratios of similar figures. And this is going to be formalizing what you did in class today with the Mighty Mascot flags. And I believe this is on page 54. So, as you saw today, if a linear scale factor is R, then the area scale factor is R squared. Okay? So if we have a scale factor going from image to image of R for the length, then the area would be R squared. Okay? So let's just do an example. And your image can look like anything. So for this one, I'm going to be like, whoa, that's my image. And this is going to be 2 meters. And the area is 20 meters squared. Okay. Now the bigger image looks like the same. And this is 10 meters. And we need to find out what the new area is. Okay. So those are our two figures. Now they could look like anything. They could be boxes, they could be just squiggles, they could be triangles, whatever it looks like, the process stays the same. So I like to make a little chart to keep things organized. So I'm going to say length, and area. So I know this is going to be, so we're going to have the original, I'm going to have a blank box, and then the new. Okay, and we're going to put any information in that we know. Okay, so information that we know. We know that the length of the original is 2 meters. The area of the original is 20 meters squared. And then we know that the length of the new one is 10 meters. Okay. Now what goes in between here, that's going to be the scale factor. That's going to be the multiplier. So I'm going to put multiplier, which can also be called scale factor. And we've worked with that before when we were doing similar figures. Okay, so we want to figure out how to get from 2 to 10. So we're going 2 to 10. So what's the multiplier here? Well, 2 times 10, that'll be 5. Okay, now that's R. Okay, so I'm going to put a little R in parentheses there, because this is what we're trying to find. This right here, this box, is what we're trying to find. So we need to figure out what we're going to multiply here to get to this box. Well, up here it says R squared. So we're going to do R squared, which would be 5 squared or 25. So we're going to take 20 times 25, and we get 500 meters squared. And that is that area. So I would write the area equals 500 meters squared. And that's going to be our answer. Okay? Now building this little table right here is going to be really handy, because sometimes you'll be given some information like you'll be given these two and you're finding one of these. Sometimes you'll be given both of these and you're trying to find these. So building this is going to be really key. So I want you to do an example now. Okay, so go ahead, build your table, and see if you can figure out what the area is for that one. So in your table, it's going to look the same. We're going to have length and area. Original. And new. Okay, and then I'm going to put all the information that I know inside. I know the length here is 12. The area here is 36. And then over here, this is 6. Okay, and then this is my multiplier. Okay, so we need to figure out 12 times what gives us 6. Well, 12 times 0.5 would give us 6. So this is going to be 0.5 squared, or 0.25. So when we multiply 36 times 0.25, we get 9. And that right there is our new area. So I would say area equals, squared. 9 meters squared. Now this one is a little bit different, right? It went from big to small. That's fine, okay? Big to small is fine. Small to big is fine. Either one, it doesn't matter. Building this table is what's going to help you figure out these out. All right, well, thanks for watching.